In this class, we're going to continue working with our third shot. So far we've worked on the bullets impacting the ground and the wall. The last thing we have to do is we're going to add some debris coming off from both of these cars when they hit. So let's see what that looks like. Okay, so I want to focus our attention in these frames. So I'm going to change this over here. This will be our working frame range for this class. Okay, and we're going to be reusing most of the things we used in the previous classes. So let's see, let's create a new geometry object. This one will be our car crash debris effects. Okay, and let's go inside. Let's see, let's hide other objects. So the first thing we're going to do is we're going to bring in both cars and we're going to end up emitting points from both of these cars. So let's see, let's object merge them. And the way to bring them in now is we want to bring in the playback. So by default, you'll notice it doesn't appear. There's nothing in there, and that's because we have to tell it to bring the transform into this object. There we go. And I'm going to call this our enemy car. We can copy this and paste it, and we can do this for the extra car. So extra car playback, and let's call it extra car. Okay, so let's start, for example, with the extra car. So what I like to do is I want to figure out when it's close enough to the enemy car, like there, and basically I'd like to scatter some points, and this will be our points that we're going to be emitting. Now, the first thing before we do anything is we need to add a time blend. So let's make sure that these are both being time blended. Okay. And an easy way of figuring out when we are near this car is just by doing an attribute transfer. So we can create a new attribute. I'm going to call it emit. So let's see, this will have an emit value of 0. So emit is equal to 0. And it can be a float. Actually, it has to be a float. And this will have an emit value of 1. And then we can do an attribute transfer. We're going to transfer from the enemy car onto this car. And you'll see immediately it's going to take a really long time. And that is because this object has a lot of points. So this is going to be very, very slow. So we need to come up with a way of speeding this up. So in my case, it's taking more than a minute, so I had to kill it. So let's find a way of doing this more efficiently. The problem is that this car has right now 500,000 points. So we don't really need all that. We just need to get the rough area where the car is. So what we can do is if we create a sphere and we connect it, let's see, after our time blend, and we tell it to be a polygon, and let's see, we add some frequency to it. That's going to be around the car, and then we can simply just ray it back against the car. And you'll see this is going to give us a somewhat accurate result. Okay, so we'll just use a minimum distance, and you'll see now with a bunch of the guide geometry. So that kind of looks like our car. It's a good enough representation of it. And the nice thing about this is that it has way less points, and now we can calculate our emit. Let's see how many points we have. Okay, we can actually scatter here as well. We can turn off our relax iterations. Let's see, we can have 10,000 points. I always like to scatter before doing an attribute transfer. Okay, and we should now see this is going to be a lot faster. Yeah, so that was very fast. And then to visualize it, I'll create a visualizer. And I'm going to call this one emit. And let's see, we want to visualize the emit value, emit attribute. And right now it's all set to red, so that's probably because by default this is going to transfer to a distance of 10 meters. So let's see, let's make that a lot smaller. let's see where the car is. So basically the red area is where we're going to end up emitting points from. So that's still too much. Let's see, 0.3. Maybe we can go 2.2. Yeah, something like that. Okay, and the next thing I like to do is just delete everything that has an emit value of 0. So we can just say emit is equal to 0. Points, delete non-selected, sorry. Like that, just delete selected. And we're only going to keep these points. And now we can go ahead and calculate our impulse based on this. So let's say, let's go to the next frame. So this will be our geometry. And in order to create the points, we're just going to copy the previous setup. So let's go here to manual. Let's go here, and I'm going to copy the impulse and the noise impulse. So let's copy. Let's go back here and let's paste it. Okay, we can go back to auto update. So let's see, in this case, I'm going to go full screen. We don't have any hit frame and we don't have a debris attribute. So I think the easiest thing we can do is just do this based on speed. That will be good enough. So we don't need to multiply it. That's it. It's just going to be a very simple grabbing the speed of our object, and then we'll fit it between a minimum and a maximum, and then we can have a ramp. So let's see, I'm going to revert the ramp to defaults. And let's see what this looks like. So we need to go somewhere where the impact happens. There we go. Somewhere like that. And let's see right now. Well, we don't have any velocity. So it'll be a good idea to, over here, create a point velocity. And we can tell it to compute from the formation. There we go. Now we have a velocity. Okay. Now let's figure out what our minimum velocity is going to be. So probably it's going to have to be a lot higher. So let's go with 10 and 20. So I want to see just some different colors in here. And let's see, I want to make sure that after a few frames where it starts to slow down, yeah, like here, in this last one, it's not emitting as much. So let's see, maybe our maximum can be 18. No, on there it's still emitting too much. So let's see, let's go with 19. And let's check out the first frames. Like that, so our color is set to 0.8. Let's see if we increase this a bit more. Okay, so I think 16 and 19 is okay. Let's see our curve. Maybe I want more of the high speeds and also more of the, I want to create an S shape in here. And then let's see, let's create a noise impulse. So we'll just be multiplying it. In this case, I think our frequency is way too high. See, maybe something like that. What about the amplitude? I think something like that is going to work. Now let's see the minimum. Maybe we can add, yeah, a bit more of the light color. So let's see. We can fit this. We can just do minus 0.5 and 0.5. That's a lot of times the default from that the noise uses. Cool. So that's going to give us enough contrast. And finally, we can now scatter. And we can do this based on our density attribute, which will be the impulse. That might be way too many points. Something like that. And let's turn off our relax iterations. And let's see. Sorry, I didn't turn it off. And what we can do also is, since we want this to be different in every frame, we can change the global seed to be $FF. So every frame this is going to change. And finally, the last thing we can do is just do a blast and delete everything that has a density less than 0.1, for example. Sorry, an impulse. So impulse is less than 0.1. Go to points. Okay, maybe we can go with 0.25. Yeah, so in this frame, let's see how many points we end up having. Yeah, it's not that many. So actually, let's see, we can end up moving our impulse a bit lower. Let's see, let's set maybe 18. There we go, now we have a bit more points. Okay, and then here we have very few points, which makes sense, right? So if we just have 3 frames where it's going to be emitting. So the first one is where the majority of them will be emitting, and that's probably when it's near 18. In this one, we'll just have a few more points emitting, but there's a lot less. And then in this last frame, there's going to be very few of them. Okay, now that this is done, one thing that bothers me about this is that it's pretty slow. Like it takes a little bit. We can't play it real time. Right, so it's not even 1 frame per second. So what I like to do is I like to cache this. Since we probably won't be changing these stop values anymore. So we can call this our, let's see, this is going to be our extra car source points. And we're going to save it under our hit file. So then cache OS. And then the same name, .vg.sc. Just in case this complains about previous frames, although I don't think it should. Actually, we can only change this cache to start at frame, let's see, 1100, and it's just going to be until, let's say, like 28. So we only need those frames. So let's tell it to save to disk. Okay, and this is done. So we can change this to read files, for example. And let's see, we can tell it when there's no file, we can tell it to, instead of report an error, to just have no geometry. So let's see, it's still for some reason reporting an error. So I'm just going to copy this. Let's create a new file. Let's paste a relative reference, and we're just going to tell it no geometry. Okay, so now if we look at this, it's real time again. So let's continue. The next part I like to do is add the velocity. So again, since this is coming from an animated source, hopefully you're starting to see that all the workflows we're using, they're pretty much applicable to any scenario. So now I want to add the velocity. So let's go back to manual. Let's go here and let's copy our velocity, direction, and magnitude. Actually, we can copy everything, all of this. So let's copy, let's go back here. I'm going to paste them. And we're going to be changing a few of them. But the idea is, I mean, most of the things that we want, the building blocks, will be the same. So let's see, let's go inside the velocity direction. So we're starting to use the normal. So we kind of need that. So let's actually probably have to rerun this. So we can create here our normal. And actually, now that I'm remembering what are the things we're doing here, since this is also already animated, we're going to be using here the speed. So it's a good idea to already set our point velocity to calculate the speed. Okay. So now we can save to file, save to disk. This is done. So now we can go back and reload the geometry. And let's see. Let's enable our guide for velocity. Cool, so let's go into our velocity direction and let's check this out again. So I'm going to visualize only this first part. So we have the velocity and the normal. And again, you can control this. So like this is going to inherit 100% the motion of the car, and like this only of the normals. In this case, I don't want it to go all the way the motion of the car because it's going to be very explosive. This car is moving extremely fast. So I'd say maybe if it's more in the direction of the normals, it's going to create like a big chaotic mess. Okay. Next, we can add our noise in there. So let's see, let's turn this back to 1. And I think, yeah, this noise now is so high frequency that it looks a bit random. So let's start to bring it down. See, maybe even more. Yeah, and there we go. Now I can see a few distinctive patches. And I'm going to go back to our noise bias and let's see how much we end up using. Maybe something like that. And then the last thing I'd like to add is I'd like to have a bit of control to make everything go up a bit. So that's very easy. We can just have a mix. So for example here, these particles are going to be shooting down. And I don't want many of the things going down. I want a lot of the things to just like shoot upwards. So we can just do this. We can just say mix it with an up vector. Just normalize it. And then our bias is going to be our up bias. Okay, let's go back up and let's see how much of that up bias we're going to use. So I don't think we want really that much. It might just be a little. It's useful to have it here in case we need it, but it will probably be best to wait until the simulation, but at least we have the option to change it. Okay, next, let's go on to the magnitude. And here, there's probably not much to change. And we're using our noise. We have over here our speed. We have our noise. Here, we're just fitting it. And remember, these values can't go above 1. So if we go back here, let's see, so our max noise is going to be 1. And let's see our minimum noise. So I like to have like a lot more variation. So there you can see some of them are getting really short, others very long. As far as the offset and the frequency goes, I think it's actually looking okay. So some of them are going backwards. We might have to do something about that. But for now, let's leave it the way it is. We have our mass, bounce and friction, and our orient, and this guy, our angular velocity. So I think we're ready to go into a sim and see what this looks like. So I'm going to go back here, go back into manual mode, and I'm going to copy all this setup like we always do, and then I can copy the clean as well. Let's go here and paste it. Okay, the next thing is we need the ground. So for that, I'm going to ghost the other objects. And let's see, in this case, I think we're going to need all this area. I mean, this is going to shoot pretty far away. So let's see. Let's go here and select maybe all this area. Let's hit enter. And if you want to select these other borders, they're in another object. So I'm going to go here, paste this, and these are under the roadside object. So if we do roadside, that is going to import these pieces. So again, we can convert it, and then we're going to create the blast in here. So let's see, maybe we want to keep all this area, and it didn't select it, so let's do it again. There we go. I'll press delete. Okay, and we can merge these two, and this is now going to become our new ground. Let's see, and this we probably want to delete non-selected. There we go. And just so this looks better in the representation, I'll make sure I select these missing chunks. So let's see. Something like that. Okay, so that's going to be our new ground. And our start frame can probably be around here. So 10 to 11, 0, let's say 6. Yeah, so just a few frames before everything starts. Let's see. Let's turn off the guide. Cool. So let's hit play. Now let's see if we have, oh yeah, we have this debris, so we don't need those anymore. Let's hit play. Okay, and our friction, I think, is way too low. They're sliding way too much. So let's see, let's go here. Can show all the other objects, hit play. Okay. So let's see. I'm going to go here to our friction. 1 and 25. Let's hit play. Let's see what this looks like from the camera point of view. So I think they're going way too high now. So let's see, maybe we want a bit less inherited velocity, something like that. And I'm also going to turn down in our direction. We have over here our up bias, so set it to 0.1 as well. That will help to have the points not go up so much. Okay, I think that's looking better. Now we need to add these cars colliders, but next I'm going to copy this exact same setup and I'm going to apply to our enemy car. So that's going to give us even more debris. So let's go full screen and let's actually move. I'm going to move all this. And over here, I'm going to copy this, paste it. And finally, we'll merge it. And that's going to be our new source. But we still need to change a few things. So we have to swap out these two, for example. So now I want to emit from the enemy car and I want to transfer from the extra car. So let's see. So we're here. We have our attribute transfer and our visualize. Let's see, let's hide other objects. Let's see what this looks like. Great, so that's what we're emitting. I actually don't want to have anything coming from the wheel, maybe, because that's just the tire, it's rubber. It's not really going to break into pieces. It's more like the body, the chassis of the car is going to. So we can go over here. Let's see. After our point velocity, and I'm going to select 3D connected geometry. Let's select all these things that make up the wheel. I'm going to select these pieces as well, and let's hit delete. Okay, and now we should end up with the whole car except that part. So let's look again at our visualize. Okay, cool. So that looks okay. So one thing to look at is that, around here, these cars aren't really crashing. I mean, they're pretty close, but we're going to be emitting again because we're very close. Now, we don't really want to have more particles coming off in this part. We only want it in the first part of the impact. So that's very easy. We can create a point bob. And we can say if the frame is greater than, so let's see, what was the first frame? 16. Okay, so if it's greater than 1115, we're going to create here a two-way switch, and we're going to say that this is going to be 0, so I'll have a constant. Otherwise, I want to use the emit value. So let's see, emit, and that is going to be saved into the emit. So emit, let's go back out. Let's look now at the visualize, and we should see that now there should be no red parts. There we go. But if we go back to the beginning, to these frames, then we are actually emitting. Okay, and then let's figure out the impulse. So let's see, in this case, this car is going a lot slower than this one, so we might need to lower this threshold. So this is going to be the first frame where we're actually emitting, and so we want to have most of the points in here. And let's see, in the next frame I was actually picking up some velocity, okay, but it's only active for 2 frames. So let's see what this looks like with our scatter. Okay, I think that's actually going to work out. We just have those 2 frames. So as you can see, this is pretty much, we're always doing the exact same thing. Let's see, I'm going to call this enemy car source points. Let's save it to disk. The same was saying, this is the 3rd exercise we're doing, it's the 3rd effect. So hopefully start to see how similar all these things are between themselves. It's all about creating a good source. It's about having good variation in your velocity. It's about having variation in your mass, friction, and bounce. It's pretty much all the same things. We just add small tweaks. The most important thing is we're doing 90% of the job in subs, and then the very last part we're doing it in DOPs. Okay, so if we look now at our file, we should see we have the points there for actually for quite a few more frames. So yeah. Okay. So let's see, velocity direction. Let's enable the velocity again. And in this case, I think I want the opposite. I don't want them to shoot out that way. I think it would be better if we stick with the actual velocity as opposed to the normals. So maybe something like that. Let's see, as far as the noise goes, maybe a bit less. And I think the up, that's okay. So the magnitude, I think that's also fine. Right, there's shouldn't be much that we change in there. Yeah, same at here, same for all these parameters. So let's have a look. I'm going to turn off the visualizer. Let's go back into our camera view, show all the objects. Let's hit play. Great. That's going to look really cool. I still think that our particles are sliding way too much. So let's see. One way we can fix this is if we go to terrain object and we go to physical, we can set the friction to 2, for example. There we go. So that's starting to look nicer. I think these pieces, a lot of them are pretty small, so they might bounce a lot more. So we can add a bit more bounce. So let's see. Our bounce is up here, so we can say 0.5. Same in here, 0.5. These are pretty much the same degree. Okay, and the very last thing we can do is create colliders for these cars. But this is really a double-edged sword. The problem with colliders is that it's going to help the simulation. It will look a lot more realistic when all the particles bounce off from them. But in the case such as this one, where you have very fast-moving colliders, and you can see our cars are going pretty fast, they can cause the particles to fly away really, really far. Like, basically adds a very big impact against the particles. So we'll try to add them, but we might not end up using them. I actually, like, from looking here, you know, they're so small that it doesn't really matter if they are inside the vehicle or not. But anyways, let's see how we can do that. So first thing we need to do is create an SDF representation for these 2 cars. And in order to do that, I'm going to go into the playback, so wherever we're extracting the transform. So we have our enemy car, we can hide everything, and I'm going to create here a collision source. So this isn't time dependent, right? Our matrix is being applied on top. And over here, I'm going to create a null, and I'm going to call it our out geo. And I'll do the same for the SDF. Now, sometimes when you have geometry that is inside an object, you'll see that it might not work out too well. So out SDF, you'll see if I go to the volume, if I probably make this a bit more high res, you'll see some parts start to fail. Let's see even more. Yeah, so see, so this is normally what you get when you have pieces that are inside the geometry. So there's a few alternatives you have. I mean, one is to make this not be so high res, be something like this, which is, you know, perfectly valid. This is going to work. The other one is you can do the trick with the sphere and then raying it into the car. That's what we did before when we were transferring. But I think for now, this works. So let's see, I'm going to leave the display in the geometry, and I'm just going to copy this, and I will go into the extra car. Let's paste this and let's see if it works. Yeah, so our SDF is also working. Okay. Let's go back, and in here, I'm going to bring these objects as static objects. And instead of using deforming geometry, we're going to be using object transform. So the difference between those two is what I explained in the first lesson. So deforming is when the actual points are changing. That's what we had to do with the debris, for example. But in this case, we can use the object transform, and that is a lot faster because the collision only has to be calculated once and then a transform is applied to it. So let's see, in this case, we want our subpath to be the enemy car playback out geo. I'm going to copy this, and I'm going to go over here to collisions, volume sample, and let's paste this path, and we'll tell it out SDF. So this will be our enemy car, and we can copy this, paste it, and this is going to become now our extra car. Now we have to swap this for extra, and same with the collision over here, so extra. Okay, and let's merge both of these in here. And let's have a look at what they look like if we turn on their collision guide and we turn off the display geometry. And we should see also that they both move. Now let's see, in this case, I think in order for them to move, maybe we have to calculate everything. No, they're still not moving. And that's because when you give it an object transform, you have to give it an object path. So that was my mistake. So I'll just paste this. And same here. Copy this and paste this. Okay, and now it's going to grab the transform from that object. That's where we're extracting it. Okay, and now, there we go. Now our cars are actually moving. So we can turn off the collision representation. And we can display the geometry again. Let's go back to our camera view. So you'll see now, yeah, the problem with colliding with these cars is that they're moving extremely fast, so they're pushing the particles really far away. I mean, we can try to counteract this by setting the, for example, the friction really high and the bounce to almost 0, 0.01. Same with bounce forward, 0.01, 0.01. See this. Play again. Let's see, maybe let's leave the bounce forward where it was. This is giving us a worse result. You can still see, I mean, the problem with this is that these cars just have such a high velocity that when they hit the particles, that's how far they go. There's not really much you can do about this. You can use another alternative, which is to use volume. So you can create a volume that has the velocity of the car, and then that's a lot easier to control. But basically here, you just have a particle colliding, and you can't really tell it how much to inherit from the collision. It will either collide or not. Another thing you might want to do is you can set this to appear later on. So here on creation frames, we can go maybe a few frames after the impacts, like for example 1120. So this might help. So now when the particles are falling, they will be bouncing on top. So you'll see in the beginning, we don't see any cars. Yeah. Let's see, let's go back. Let's see if... Yeah, and actually there we can see some of them colliding. Yeah, and I think this is actually starting to look nice. I think we're ready to instance some geometry. I'm going to save this. And now I want to show a different approach to copying geometry. And that is, we're going to be using geometry that already exists. I'm actually going to load it. So this geometry is under, if we go to our job, and then let's just browse from there. So if we go to class 1, CRC30. So in here, I left this called car parts, and you can see it's all cached actually as a sequence. It's starting from frame 1. So there's 127 of them. So let's see, let's hit accept. Let's visualize this. And let's go, I'm gonna go to frame 1. So basically these are different parts of the car that are being cached on the origin. And the idea is that we're going to be instancing each one of these onto some of these points. So that's a very common thing. Like a lot of the times you're going to be provided with the debris. You're not going to make them the way we did in the previous lessons. You're going to receive a cache such as this. Right, so we have objects like this. So the idea is to copy each one of these objects onto these points. And this is actually one of the most efficient ways of instancing geometry. And for that, we need two things. So first, we need our p-scale. So for that, I'm going to create a point bob. And inside, we're just going to bind our mass, like we always do. We're going to fit it from 0.75 to 1.25. And we'll have our min and max p-scale. This is going to be our max p-scale. Okay, and now we can save this to p-scale. Okay. And then the one other thing we're going to be needing is to create an attribute, which I'm going to call the shape attribute. And it's going to have a value between 1 and 127. If we bring back that file, so if we go here to car parts, you'll see it goes from 1 to 127. So that's going to randomly choose one of these files. That's the idea behind it. So let's create a point bob. Let's see, let's go up to a frame where this exists. And we can grab, since this is coming out from a simulation, we can grab the ID. We can say random. And we can fit this random between 0 and 1. And in this case, our min and max parts. And then I'm going to make sure that it's an integer. So let's do a float to integer. And let's export it here. And I'm going to call it shape. Okay, and let's make sure that this goes from, let's see, 1 to 127. So if we check here, we have, it goes all the way from 1. And the reason why it doesn't go to 127, I think we might have to do, we can do a, instead of a float to integer, here we can do a ceiling. So it's going to convert it to a value above, for example, so 0.1 is going to become 1, 0.9 is going to become 1. Basically, when you're above the decimal, it's going to round up to the highest number. You can see there, that drawing kind of shows that after you pass the number, everything else is already rounded up to the next number. So let's see, this goes from 2 to 127, so we can change it to 0. That's why anything that's 0 point something is going to become 1. There we go. So this is going to be our shape. Okay, and the way that we can get this geometry into these points is actually pretty easy. There's this instance node, and the way it works is there's this instance path attribute, and if we give it that attribute, and that attribute has a path to a file, it's going to instant it onto the point. So we have to do now, and I'm going to do this in a wrangle because it's the easiest way, is we can go here, and I'm going to create a string attribute. So I'm going to start with s at, so instance path, and that's going to be equal to our path. So if we open the file again, we go here, and we just click on this. I mean, we can just load one of them. Okay, and we can select this, so do control copy. And if we paste this here, and we look at the result, we will see we're actually copying that same piece everywhere. So right now, we're always loading parts 1. So what I'd like to do is to replace this one with our shape. And there's a very easy way of doing that in Bex, and that is there's a function called sprintf. So sprintf. And what this allows you to do is you can give it a string, and then you can put something like modulo or the percentage sign and d, for example. And what that allows you to do is you can give it here an attribute, like for example our shape, and what it's going to do is it's going to replace that %d with the value of the shape. So let's see, we have a comma there, let's get rid of it. Okay, and you can now see our instance is thinking, and that's because if we look at our instance path, you can now see we have different values in there, so it's reading from different files. You can now see we have lots of different files in here, each piece is unique. So the last thing we have to do is set the piece scale. So by default, I want the maximum set to, let's say if we set it to 1, it's going to end up being the actual size of the object. If we set it to 0, it's going to be kind of small. So you can see this is the actual size of all those objects. Let's look at it from the shot camera. So let's see, we can go, for example, 0.75 and maybe 1.75 if we want some of these objects to be bigger. Okay, and let's create a flipbook. Okay, and this is done. So let's have a look. So it looks great. There's just a few things. So there's some pieces, you can see especially here, there's some things that are flying away really, really far. So we have to fix that. So let's see. I want to look at the points. Let's just ghost all the other objects. Let's keep going. So yeah, so we have some points in here. So I'm guessing that's still being caused by the collision. Yeah, so after this frame, when we add the car, some things are shooting really fast. So one way we can fix this is by using a pop speed limit. So pop speed limit, there we go. And the way this node works is basically you can set a minimum speed and maximum speed, and none of the particles will be able to go slower or faster than that. So in our case, we have to figure out what our speed is. So we can do that if we, let's go to the first frame and we click on the debris and we go under geometry. So by default, we're not going to have any speed, so we have to create it ourselves. We just have the velocity, so we can do that very easily with a wrangle, and I'll just say speed is equal to the length of the velocity attribute. So let's see, speed, and I want to see what's the maximum speed that we're dealing with. So 23. Yeah, I think it never goes above 23. So, okay, now that we know that, we can enable here our maximum speed and we can set it to 23. Now let's see now. We shouldn't see those points flying so fast as before. So they still are because of the collision. So let's see, another solution might be to change this to start even later, so around frame 1030. Okay, and let's go here. And it looks like now all our points are contained in here. Let's see, let's go to our shot camera, let's show all the objects, and I think that might be it. So let's now make a flipbook of this. Okay, and the flipbook is done. Let's have a look at the final result. Great, that's much better. Now we don't get any crazy pieces flying off. Awesome.